Well, hello everybody. This is, I think, my first circuit video going up on this blog. I think the blog offers, I guess, more flexibility with how I present these projects, and I guess, maybe some people on Facebook may not find this so interesting. So if you're reading this blog, you're here because you want to be here. Anyhow, so this, I think, is a good way to start the blog too. A gentleman that works at my school, he retired from Microchip. He showed me a document that Microchip had published called Tips and Tricks for 8-bit microcontrollers. And what's cool is that they give you these little small projects and they show you how you can accomplish them using this trick or whatever. And I just figured I'd start on page 1 and work my way through as much as I could, at least, before I got bored with it. I think it's a really good learning tool. So this one is the first trick, or the first hardware trick anyway. And what this is a I guess a dual frequency oscillator. And what I'm using is basically an RC circuit to create an oscillator. I've got these two resistors and this capacitor right here make up the oscillating circuit. I guess that combined with this PIC. This LED right here is the clock out function. It's actually running at 1/4 of the frequency that the oscillator is driving into the PIC. This light right here, I've just got it used to, it indicates if I'm looking at the higher frequency or the lower frequency of this setup. And the general idea is, depending on what this bit right here, this pin right here is at, what state it's at, either if it's a high output or a high impedance in, it determines how these two resistors behave or how they're interacting. In the scenario where this is blinking really high, this right here, this bit is being output high, so it's basically putting out about 5 volts, just about what that is. I made these two resistors the same value, and then you basically have two resistors in parallel, and then when you find that equivalent resistance, it's simple. It's a simple issue of finding it. This is, I think it should be close to 20 hertz with whatever value I have picked for these. I can't remember what that is off the top of my head. Anyway, and then what happens is I got this push button right here, and it will let me toggle between what I have coming out of this bit. So right now I've got a 5 volts coming out, or approximately 5 volts, which means that this is flashing at the higher frequency of the two it can have. When I push this button, what'll happen is well, I'm using this for debounce. It's all this is just a well, I think a quad 4 or yeah, quad 4 NAND gate. Anyway, I'm using it to debounce this button. What'll happen is I'll trigger the interrupt, and then this will go from having a high output to high impedance, which will essentially make very little current go through this resistor right here, so it'll almost act like an open, and then I'll only have this resistor with this capacitor, and that will slow down the frequency. It'll actually cut the frequency in half because these two resistors are the same value. So I'll go ahead and demonstrate. And you'll see it'll take it a minute before it registers what happened, and that's because I'm running at such a low frequency. If I sped the frequency up a lot faster, it would appear as if it was almost instantaneous. But anyway, this is a dual frequency oscillator, and it's made using this PIC and using a interrupt, which, as you can see, takes even longer to switch back now. And we're waiting. There you go. That is a dual frequency oscillator. And you can control the speeds by picking values for the two resistors and the capacitor. I think I'm going to put my MATLAB code and my code for this PIC online as well, so that you can see what I did. The MATLAB code I used to help me pick what value of these resistors I wanted. And my goal there was just to make so this LED was flashing slow enough that you could actually see it flash. I think that concludes this presentation. Thank you.